Good morning, one and all. Welcome to the third lecture of Module 5 for the course ME404 Industrial Engineering offered to the 8th semester Mechanical Engineering students. I am Mathew Baby, Assistant Professor, Department of Mechanical Engineering at Rajagiri School of Engineering and Technology. And in this particular lecture, Lecture 3, we'll be dealing with the basic concept of inventory, the different types of inventory, the cost associated with maintaining inventory, the general terms in inventory and inventory control, and we'll also see the various kinds of inventory models. Specifically, we'll be dealing with purchase models for inventory with instantaneous replenishment under two conditions. One that allows for shortages, the second one that does not allow for shortages. So without further ado, let's get started. Now we'll start off our discussions of inventory control by discussing what the term inventory means. Now, inventory is goods and materials which are held in stock. Now, the practice of keeping inventory is not necessarily only seen in industries or businesses. It is also a concept that is widely practiced in households. For example, you generally buy groceries and store them rather than going and buying groceries as and when needed. Now, you generally buy groceries and stock them due to the fact that it is very difficult for us, or it becomes a tedious task for us to go out and buy groceries every time they are needed. And it is not only a tedious task, it's also a costly and time consuming task. So that is why we generally in households have a practice of keeping keeping groceries as inventories. We buy them and stock them. So such a system of maintaining goods and materials in stock or holding materials or goods in stock is referred to as inventory. Now there are different kinds of inventories or different types of inventories that are generally maintained by companies. They can be raw materials inventory, which is the storage or stocking of raw materials which are later to be processed and converted to finished goods. Then there is the work in progress or work in process inventory, where you store or temporarily store materials before they pass on from one station to another. So intermediate storage of raw materials during their processing is referred to as work in process or work in progress inventory. The third kind of inventory is the finished goods inventory, where we stock finished goods before they are being sold off to the potential consumers. So that particular kind of inventory is called as finished goods inventory. And the fourth kind, which is not necessarily of great importance, it's called the spare parts and tools inventory, where we have a habit of keeping spare parts for machines, equipments, etc. of the company. And you also have inventories of tools, or you keep tools in stock. So such kinds of inventories are called as spare parts and tools inventory. But the most important inventory as far as a business or in manufacturing industry is concerned is raw materials inventory, work in process inventory, and finished goods inventory. Now, inventory basically is capital that is blocked for a certain period of time. That means when you buy a certain amount of material or a certain amount of good and you stock it, you are investing a certain amount of capital which is blocked for a certain period of time until these goods are being utilized. For example, if you produced a certain amount of finished goods and keep it as stock, the finished goods, the expenditure that you have made in procuring the raw material, processing it and converting it into finished goods and storing it, that expenditure is only recovered when you actually sell that particular good to the consumer and get your price or get your return. So generally inventory, it shows capital that is blocked, or it represents capital that is blocked for a certain period of time till the stock is cleared or used up. But the process of keeping inventory is very, very vital in the case of businesses and manufacturing process, because it acts as a buffer to ensure smooth production. Now, if you don't have a system of keeping inventory, when you look for a particular raw material or a particular spare part or a part or a good that has to be used for production purpose, you might have to wait for that particular good because it might not be available at that point of time. So such a case or such a situation will result in a delay in production. So this cannot be allowed, and that is why we generally have a practice of keeping inventory. So it acts as a buffer to ensure continuity of production or smooth production without much interruptions. But keeping inventory at very high levels is also a problem. Buying and storing goods and materials in large volumes is also a costly affair, where you have to procure them in large quantities, where you invest large amounts of money, and you also are required to pay expenditure on maintaining that particular stock or keeping. There's a cost called carrying cost, where there's a cost involved in carrying a large amount of inventory. So the total cost will be very high if you have very high levels of inventory, and similarly the inventory cost will also be very high in the case where the amount of inventory is kept is also very low. So there should be an optimal level of inventory that needs to be maintained in a company. So inventory control, it becomes a very, very important decision, or it's an important function that is performed in an industry. So inventory control in general is nothing but the planned approach to determine what is to be ordered, when the order has to be placed, and how to order and stock things so that the cost associated with buying and storing are optimal and without interrupting production and sales. So if you stock in too low a volume, the cost will be high. The cost associated with purchasing will be high, but the cost associated with storing will be low. If you store in large volumes, then the cost associated with storing will be high, but the buying cost will be low. So in net effect, the total cost for extremely low amounts of inventory and extremely high amounts of inventory will be high. So there should be an optimal level of inventory that is maintained. And this particular maintenance of optimal level of inventory is to ensure that there is no interruption in the production and sales of your products. So inventory control is defined as a planned approach to determine what to order, when to order, and how to order and stock, so that the cost associated with buying and storing are optimal without interrupting production and sales. So in inventory control, the basic objective is to maintain an optimal level of inventory. If the level of inventory maintained is too low, it will result in two things. One, it affects the production, whereby the production ceases due to the lack of availability of raw materials, spares, tools, etc. So due to lack of available inventory, it can cause a delay in the production. Okay. At the same time, lower amounts of inventory will require you to make purchases on a frequent basis. So you might have to give multiple number of orders. So the number of orders that needs to be placed in a particular amount of time will be high. This will also lead to higher amounts of inventory cost, because the total cost of inventory is also dependent upon the number of orders that you place. Every time you place an order, there is an associated cost associated with that particular placement of order. So whenever you have higher number of orders that needs to be placed, the total cost of inventory also generally goes up. So low levels of inventory, it will affect or delay the production. At the same time will result in high cost. At the same time, the other extreme case where you will maintain very high amounts of inventory, this will result in too much inventory cost. So in inventory control, our basic objective is to maintain an optimal level of inventory so that it does not affect the production, and the cost in maintaining that level of inventory is not too high, or it is optimal. So we'll discuss certain basic terms that are used in inventory control. Now, in this particular figure that is represented here, you can see that along the y-axis, you have the stock level or the quantity of stock that is kept, that is indicated on the y-axis, and on the x-axis you see time. So this particular plot shows a variation of stock level with time. So this particular figure, it shows a variation of stock level as time progresses. So the amount of inventory maintained or the quantity of a particular item that is stored, it is not always constant. As it is used up by production purpose, the quantity generally decreases. Okay, and at a particular the stock level reaches a particular point, you actually start placing an order, and after some time you receive the order, and then the stock level goes back up. So we'll discuss the major terms involved in inventory control by using this particular figure, which depicts the variation of stock level represented on the y-axis as time progresses, which is represented on the x-axis. So the first term that we are going to discuss is the demand. So the term demand is basically the number of units that is required per unit time. So on a daily basis, on an hourly basis. So based upon the number of units of a particular material required in one day, in 1 hour, etc. That is what we call as demand. So per unit time, the amount that is required is referred to as demand. So as time progresses, these stocks of particular materials, they get consumed, and that is why you see that there is a decline or there is a reduction in the quantity of stock maintained as time progresses. So as time increases, with the initial level of stock that you have, as time increases, the stock level comes down. So that is why you use the term demand. So demand is nothing but the number of units that are required per unit time. Then we move on to a quantity called maximum inventory. So the maximum inventory is represented by the uppermost dashed horizontal line. So this is the maximum amount of stock or maximum amount of inventory which should be kept in stores at any point of time. Okay, so keeping anything more than this would result in too high a cost. So there should be a maximum inventory that should be maintained. Okay, then at the bottommost level near the x-axis, there is a horizontal dashed line which indicates the minimum amount of inventory that should be maintained. So the minimum inventory, it should be the minimum amount of stock that needs to be maintained at any point of time. Okay, and the standard order is basically the difference between the maximum inventory level and the minimum inventory level. So the difference between maximum inventory level in terms of quantity and the minimum inventory level here in terms of quantity, this particular difference is referred to as the standard order. Okay, and then there is an average working inventory, which is nothing but the average of the maximum and minimum inventory levels. Okay, when you sum up these two and take an average, that particular level of inventory is referred to as the average working inventory. So the difference between maximum and minimum inventory is referred to as the standard order or the working inventory, and the average of maximum and minimum inventory is called as the average working inventory, which is represented by this particular horizontal dashed line. Okay, now the next important term is reserve stock or safety stock. Now the term safety stock is a stock. Safety stock is nothing but a stock that is maintained to meet unanticipated demand. So if there is a sudden fluctuation in demand, okay, a sudden extremely high demand which cannot be met using the regular inventory level. For example, the demand for a particular product has gone up. Therefore, it might require you to use more raw materials than you regularly use. So in such a case, to ensure that you do not run out of raw materials in the case of such unanticipated demands, you always have to maintain some minimum amount of stock. That particular minimum amount of stock is called as reserve stock, safety stock, buffer stock, or it is also commonly referred to as minimum inventory. So the term safety stock, it represents the stock that needs to be maintained to meet any kinds of unanticipated demands. So the term safety stock is also known as reserve stock. You might also alternatively call it as buffer stock or minimum level of inventory. Now, as I told you, at the beginning of time, we had an inventory level equaling the maximum inventory level. So as time progresses, the stock level declines or it reduces as the stock is being consumed. So when that particular material is used up for production purposes, the quantity that is available in the inventory, it comes down with time as time progresses. So whenever you reach a particular level, there is a particular level at which you actually place order for that particular item to be purchased again. So that particular point is referred to as reorder point. So reorder point is a point at which stock replenishment or stock refilling should be initiated. So when the stock comes down, you should make an order for that particular stock to be replenished back up to its maximum inventory level at a particular point of time. That particular amount of inventory or the quantity of stock at which you trigger a reorder or trigger an order for refillment of that particular item. That particular level of inventory or that particular point or the level of inventory at which you make a reorder or place an order for refillment is referred to as a reorder point. Okay, so reorder point is a point at which stock replenishment or refill should be initiated, and when the stock level reaches reorder point, you place an order. Now, the reorder quantity is a quantity to be ordered at the reorder point. The amount of quantity that you order at the reorder point. When you reach the reorder point, the amount of quantity that you place an order for is called as a reorder quantity, and it is generally the difference between the maximum inventory level and the minimum inventory level. Okay, so when you place an order, it is not necessarily seen that there is always a delay between placing an order and receiving the order. Okay, so that particular time or the time between placing a reorder or placing an order for a particular item to be refilled and receipt of that particular item, that particular time is referred to as lead time. So it's a time between reorder and receipt of the ordered materials. So this particular time interval is referred to as lead time. So lead time is the duration of time between placing of order and receipt of items. Now this particular lead time is due to the fact that there is a process that needs to be carried out when placing an order. Okay, generally when you place an order, it is not an immediate replacement or immediate replenishment, but rather once you place an order, it takes a certain amount of time for the supplier of that particular item to process the order, to collect and then supply the items that are required. So if you are placing an order, if you are regularly placing an order, then what the company or the supplier can do is they can keep things in stock, okay, thereby reducing the lead time. So if you can reduce the lead time to as low as possible, then the amount of inventory that you need to maintain will be generally very low, because you are sure that your supplier can supply an item at an order without any delay. So the lead time, it depends upon the company, the supplier. So the reorder level, the point at which you actually trigger an order, it depends upon the lead time and the consumption or the demand during lead time. So if the demand during the lead time, if the lead time is very high, then the demand or the amount of inventory that is consumed during that particular lead time, which is equal to this much. Okay, during that particular lead time, the inventory level has dropped from the average working inventory level right down to the minimum inventory level. So if your lead time is low, then the demand during lead time will also be low, assuming the demand to be constant. So here you can see that the demand is constant because you have a linear line representing the consumption. So the reduction in the stock levels is a linear reduction that shows that the demand for the product is generally very constant. So if you have a constant demand, then if you can have very low lead times, then the reorder point will be much more closer to the minimum inventory level. Okay, so the demand during the lead time is of very high importance. So if you have a high demand rate, then generally you have a very high reorder point. That means the reorders are generally triggered at a higher inventory level. If your demand rates or your demand is generally lower, then your reorder points or the reorder level will be generally higher. Okay, so once you receive an order at the end of the lead time, here it shows that the inventory is being replaced instantaneously. That's why from minimum inventory level, the inventory goes up to maximum inventory level without any change in time. So it's a vertical line that you see here. That means the time difference between the replenishment of stock from minimum level to maximum level is instantaneous. So if you see that the stock replenishment line, the downward line indicates the consumption line where the stock is being consumed, and the upward line that indicates the stock replenishment line. So the stock replenishment line, if it's vertical, that shows that the replenishment or refillment of the stock is instantaneous. That means there is no delay between receipt of order and restocking the items back to maximum level. So this particular cycle generally repeats, assuming that the demand and the lead time remains constant. So these are some of the common terms that are used in inventory control. So I hope things are very clear. Okay, now we'll understand or we'll come to know more about inventory control once we go into the details of inventory control and we work out certain problems. Now, the basic objectives of carrying out inventory control. We carry out inventory or we actually practice inventory control so as to ensure that products and raw materials are available so that the production and delivery of products are not affected. Okay, so it ensures that the delivery of finished products as well as the production process itself is not affected due to lack of availability of products and raw materials. So inventory control ensures the availability of products and raw materials so that the production process and the delivery of products is not affected. It also helps you to ensure that not too much capital is invested in inventory. That means the cost is kept to an optimal level. It helps you to ensure that there is timely replenishment of inventory. That means as inventory is being consumed or the stock is being consumed, then it is the basic objective of inventory control so as to ensure that this particular depreciation or decrease in stock level is replenished and you have sufficient amounts of inventory to carry out production or carry out production without affecting it. The last objective is to maintain safety stock, a certain amount of safety or reserve stock or buffer stock to meet variation in demand and lead times. So if there is a change in the demand, the rate at which a particular item in stock is being consumed, that indicates variation in demand. Then a variation in lead time. If you place an order and you expect that particular order to be fulfilled by your supplier in 2 weeks time, that is a time that we call as lead time. So the time between the order placement and the receipt of the order at the facility or at the company is referred to the lead time. Any change in the lead time will also lead to certain products not being available for production. It might affect or it might cause a delay in production. So as to ensure that this variation in lead time or variation in the demand does not affect our production, we have to maintain a minimum level of stock always. The stock level should not go, generally should not be lower than this particular level. That level is called a safety stock, buffer stock, or reserve stock. Now this level of inventory always has to be maintained. That is also a major or important objective of inventory control. Now there are various costs associated with maintaining inventory. Okay, so we'll talk about the general major costs associated with inventory. The first cost is called as a purchase price or the purchase cost, which is the price or the cost for purchasing unit material. Unit quantity of a material, the price at which you buy it, that is called as a purchase price. The second cost is called as the ordering or procurement cost, and this is the cost associated with making an order. Okay, like calling quotations, processing quotations, placing orders, receipt of orders, and carrying out inspection on the received materials. So the received stock has to be first of all inspected before it moves into the actual inventory. So all the costs associated with ordering like calling quotations, processing quotations, placing orders, receipt and inspection of materials, etc. are classified or put under ordering or procurement cost. Then there is a cost called carrying cost. Now the carrying cost is cost like shortage cost, the handling cost, depreciation, transportation of inventory. Okay, so those kinds of costs like storage, the cost involved in storing that particular item. Not shortage, but sorry, it's storage cost associated with storing an item. You are renting a space or you are basically assigning a certain amount of space to keep this inventory. So there's a certain amount of cost involved in maintaining and assigning that particular space for storage. So there's a storage cost, then there is a handling cost, moving materials, okay, from the storage area to the required area. So there's some amount of material handling involved. The cost involved in that is called as handling cost. Then there is a depreciation. The value of this particular stock, it generally reduces with time. So there's a depreciation factor. Then there is a transportation cost. Transportation, it involves movement of inventory from one location to another, that is outside the plant. That is called as transportation. Okay, movement of materials within a plant or a facility is referred to as material handling. So that is what we generally put down as handling cost, whereas transportation involves transporting a material between facilities. So material transport takes place outside the facility. So that is called as transportation cost. And then there is the insurance, that has to be the insurance cost associated with insuring that particular amount of inventory. So all these come under the carrying cost. And the last cost is the shortage cost, and this is generally due to the fact that demand for a particular product or a material might exist, but there is no product or material that is available in stock. In such a situation, we are basically under a situation of shortage. So whenever we have a shortage where demand exists but there is nothing in stock, we incur costs like back order cost, where an order is taken but fulfilled at a later date. That is called as back order. So the cost associated with back order is called as back order cost. Then there is loss of future sales, okay, and loss of customer goodwill, etc. So all these costs together are put together as the shortage cost. So these are the general costs that are associated with inventory. Now we'll have a look at the cost associated with maintaining a particular quantity in inventory as inventory. So the total cost of inventory of maintaining inventory is basically the sum of shortage cost, procurement costs, and carrying costs. Okay, so the total cost for inventory is a sum of the procurement cost, okay, the out of stock or shortage costs, and the carrying costs. Now, as the order quantity increases, okay, so along this y-axis, in this particular graph, along the y-axis, we have the total cost in monetary terms. Here it is specified in dollars. It might be in any other monetary terms. Okay, it can be any other currency form. So the total cost is represented on the y-axis, and the order quantity or the inventory level is basically plotted along the the order quantity is basically plotted along the x-axis. So the order quantity is depicted as Q. So as the order quantity increases, okay, for every order, the amount that you order, the quantity that you order at every reorder, that's what is the order quantity. So as the number of items that are ordered per order increases, the carrying cost increases because you're dealing with more amounts of inventory. Okay, but at lower levels, at lower order quantity, so you can see that as order quantity increases, the carrying cost increases. But the procurement and out of stock or shortage cost, they decrease as order quantities increase. So at very low order quantities, the procurement and out of stock costs are extremely high because you have to make multiple orders. So the number of orders that needs to be made, the frequency of ordering will be high when you have low order quantities. Okay, that is why you see that the procurement cost is very high, and chance of you having a shortage is also very high at low order quantities. So that is why at lower order quantities you see high procurement and out of stock costs, and as the order quantity increases, we see that the procurement and out of stock cost decreases. So this shows that there is a decrease in procurement and shortage costs as quantity of order, the order quantity is increased. Okay, so you see that there are two conflicting costs, or two costs or costs which are conflicting in nature or opposing in nature. One cost which increases with order quantity, another two costs which decreases with order quantity. Okay, so the total cost, as I told you, is the sum of the carrying cost, the procurement cost, and out of stock cost. So the total cost at this particular point, or this particular quantity, order quantity, is the sum of this particular, that is this particular cost plus this cost. So you add up those two, you get the total cost. So the total cost curve, as you see, it first of all, the total at low levels of order quantity, the total cost will be very high. Okay, as the order quantity increases, you see that the total cost, it comes down, it hits a minimum, and then above that particular quantity, if you make an order, then you see that the total cost again keeps on increasing. That is due to the conflicting nature of carrying costs and procurement and out of stock cost or shortage costs. So this particular point at which you see that the total cost of ordering is minimum, that particular order quantity corresponding to lowest total cost. So the point at which the order quantity corresponding to which the total cost of inventory is kept to minimum, that particular inventory or the order quantity is indicated as Q star, and Q star is the economic order quantity. We call Q star as economic order quantity, or EOQ, and this is the order quantity corresponding to which the minimum, the cost, total cost is kept to the minimum. And this is generally seen where the procurement cost curve and the carrying cost curve meets. So that will be the point of total minimum cost, and the order quantity that corresponds to the minimum total cost Q star is referred to as the economic order quantity. So that is why whenever you make an order, it is generally economic for you to make an order in a specific quantity. You do not make an order for an item in too low a quantity or too high a quantity. Too low a quantity will result in high costs, and too high a quantity will also result in a higher total cost of inventory. That is why we generally have a particular order quantity that you generally place orders in. So your orders will be always in quantities equaling to EOQ. Okay, so this graph is referred to as a cost trade-off graph, and it shows how the total cost varies with the order quantity or the quantity ordered. So you have to clearly understand the importance of economic order quantity. We'll be working out problems on EOQ in the next lecture, that is lecture number 4. We'll be discussing the theory of EOQ, that is, we'll be deriving mathematical formula that will help us calculate the quantity called EOQ or Q star in the coming slides. But the problems, we'll work it out as tutorials in the next lecture. Now coming to inventory models. Now inventory models, they are concerned with the quantity as well as the time of purchase. Inventory models are classified into two kinds. There are purchase models and manufacture models. Now purchase models are used for inventories or items which are brought and stocked, whereas manufacture models are used for situations where the company manufactures items and then stocks them. So the only difference between purchase model and manufacture model is that in purchase model, the company is involved in purchasing items from external agencies like their suppliers and then stocking them. Whereas in manufacture models, it is concerned with making the required item in-house and stocking them. So all inventory models, whether it is a purchase model or a manufacture model, it deals with the quantity and time of purchase. Okay, so purchase models specifically deal with how much of an item is to be bought and when they have to be bought, whereas manufacture models deal with how much of an item is to be made and when they have to be made. So in both these cases, we will see in inventory models, we'll identify or quantify a term which is referred to as economic order quantity or economic batch quantity. So this is a quantity that this is a quantity corresponding to which the total cost of inventory is kept to a minimum. So when you order or make items in this particular quantity, the total cost of inventory will be the minimum. So the value of the quantity of items corresponding to which the total cost is minimum is referred to as the economic quantity. Now this economic quantity, when you buy items from suppliers, it's called as economic order quantity or EOQ, and when you are concerned with manufacturing items, this economic quantity is referred to as a economic batch quantity or EBQ. Now in our syllabus, we'll limit our discussions to purchase models where companies buy items which are required to be stocked from external suppliers. So we are only concerned with purchase models. Now purchase models, we are only dealing with purchase models with instantaneous stock replenishment. That is, once a particular order has been placed and the order is received, the value or the stock level, the inventory level is replenished to the maximum inventory level at an instant. That means without any delay, as soon as the stock is received by the company, it is assumed that the stock level goes back up to maximum level without any time being consumed. So such kinds of stock replenishments are referred to as instantaneous stock replenishments. So these kinds of stock replenishments, they can be represented on the stock consumption graph or inventory level graph, variation of inventory level with time. So these two graphs show the variation of inventory with time. So both of the figure 6.1, you can clearly see that as soon as an order is received, you see that the stock level goes up to the maximum level without any change in time. So it's an instantaneous replenishment. So we are concerned with purchase models where we have instantaneous stock replenishment. So these purchase models are again of two types. There are purchase models which does not allow shortages, and there are purchase models for which shortages are permitted. Now in both the purchase models which allow for shortages and which does not allow for shortages, in both the cases there are some certain common characteristics. In both the cases you see that orders are of equal sizes. So every time you give an order, so the order will be of equal size and they are placed at regular intervals. So that means the order is generally periodic. So at a fixed time interval, say time equal to t, time is equal to t, you periodically place an order of equal size. And you assume that in both these models, purchase models, the replenishment is instantaneous and the items are consumed at a constant rate, or rather the demand is constant for an item. That is why you see in both these figures, you see that the rate at which the inventory level decreases with time, it's a constant. So you see straight lines in both the cases. So we assume that, it is assumed that in both the models the items are consumed at constant rate or the demand is constant. The difference between purchase models with instantaneous stock replenishment without shortages and with shortages. In the case of the model which does not permit shortages, it does not allow the stock level to go into the safety stock. That means as soon you are in this particular model, it's assumed that the order is received as soon or before the inventory level hits the safety stock or the minimum inventory level. In the case of inventory model, the purchase model with shortages being permitted, the stock level is allowed to move into the safety stock or the buffer stock. That means stock level for a particular item can go below the minimum inventory level into the safety stock. So that is what you see here. Okay, so we will deal with these two models in detail. So first of all, we'll take purchase models with instantaneous stock replenishments without shortages. Now these kinds of models without shortages are generally referred to as the basic inventory model. So we'll talk about the basic inventory model, which are purchase models with instantaneous stock replenishment and which does not account or allow for shortages. So they are called as a basic inventory model. So we'll deal with this basic inventory model first. Now coming to the very first kind of inventory model, it's a purchase model with instantaneous replenishment and without shortages. Now this is depicted in the figure that is shown in the slide. So along the x-axis we have the time and along the y-axis we have the inventory level. At time t is equal to 0, you have an inventory level that equals q, and as time progresses we see that the inventory level declines at a constant rate. So this means that the demand in terms of number of units, the demand is constant. That's why you see a linear line. So the inventory level, it keeps on decreasing with time, and at a certain point of time, as the inventory level keeps on decreasing, at a certain point of time, that's a reorder point, we place an order, okay, and we place an order equal to the order size Q. Okay, so this is the maximum inventory level at time t is equal to 0. The inventory level is at maximum, is equal to Q, and as time passes, at a certain point of time, we place an order for an order size equal to Q, and at a certain point of time after the order, you receive the ordered items. So at the time you receive the ordered items, the inventory level has gone. By the time you receive the ordered items, the inventory level has gone from Q to 0. That is the minimum inventory. Sorry, it has gone down, not 0, but the minimum inventory level. Okay, and once at that particular point you receive the order, the stock is replenished and it goes back instantaneously up to the maximum level. So the order or the inventory level, it goes from the maximum inventory to the minimum inventory during a time period T. And after the stock has been replenished, again it has been consumed at a constant rate. So the demand remains constant. At another certain point of time, you place an order size equal to Q, and after a certain amount of time, you get that particular order, it's instantaneously replenished. So the time interval between two subsequent orders, that is this order point and this point, is generally equal to T. So the time between subsequent orders is generally T, and the average inventory level is given as half of Q, which is half of the maximum inventory level minus minimum inventory level. So this figure depicts the purchase model without shortages. So nowhere can you see that the inventory level going below the minimum value or into the safety or reserve or buffer stock. Now in this particular model, let us assume the following. Let D be the annual demand in terms of units. So the value of D is constant, the rate at which units are consumed. So the annual demand in terms of units is represented by D. The ordering cost is represented as C suffix O, CO, which is the ordering cost per order. So every time you order, you incur a cost equal to CO. Now CC, it represents the carrying cost per unit per year. Okay, so the cost of carrying a single unit of product over a time period of 1 year is given as CC. And D, as I told you, it's an annual demand over a period of 1 year. P is a purchase price, that is the price of an individual unit, and Q is the order size. So the total cost of inventory over a year is taken as the sum of the purchase cost plus the ordering cost plus the carrying cost. So the entire cost of inventory over a time period of 1 year is the sum total of the purchase cost, the ordering cost and carrying cost, where the purchase cost will be equal to D into P, that is the annual demand over a period of 1 year multiplied by the purchase price per unit. So this is in terms of units multiplied by price per unit, so you'll get a cost value. So annual demand D multiplied by purchase price per unit P will give you the purchase cost. So if you are buying say 10,000 units over a period of 1 year, and the cost of 1 unit, the purchase price of 1 unit is 1 rupee, then the total purchase cost will be equal to demand over the year, that is annual demand 10,000 multiplied by 1, which is equal to 10,000 rupees. Okay, the ordering cost is basically equal to the number of orders per year multiplied by the ordering cost per order. So first of all, you have to calculate how many orders are placed over a period of 1 year, and for each of those orders you incur a cost of CO, that is the ordering cost per order, and the number of orders per year can be calculated as D divided by Q, where D is the annual demand and Q is the order size. So if over a period of 1 year you have a demand, just like the previous example, over demand of 10,000 units, and your lot size Q is equal to 1000. So that means every time you order, you are ordering in a quantity of 1000. So that means in a year where you have 10,000 units as demand and you are ordering each order in units of thousands. So every order will contain 1000 units. So over the year you will have a total of 10,000 divided by 1000, that is 10 orders. So the ordering cost will be D divided by Q multiplied by the ordering cost per order. And the carrying cost will be CC, which is the carrying cost per unit per year, multiplied by the average inventory level over the entire time period. So the average inventory level, as I told you from this particular figure above, is given by Q by 2. So Q by 2 is the average inventory level maintained over a time period of 1 year. And for a single unit, you take the average inventory level over the year, because the inventory level is never constant. At one point of time it is very high. As time progresses, it it decreases, and at a certain point of time it becomes equal to 0. Then all of a sudden it goes back to maximum inventory level. So the inventory level over an entire time period at different points of time over a time period of 1 year is not always constant. That is why to calculate the carrying cost, we ascertain the average inventory level over the year, and this is taken as Q by 2. So you multiply that average inventory level Q by 2 by the carrying cost per unit per year CC. So the total cost will be the sum of purchase cost plus ordering cost plus carrying cost. So the total cost over a period of 1 year is the purchase cost of the purchases made over the single year plus the ordering cost during that particular year and the carrying cost during that particular year. So hence the total cost TC per year is written as the purchase cost over the year, that is D into P, plus the ordering cost per year, which is D by Q into CO, plus the carrying cost over the year, that is Q by 2 into CC. So this is the total cost that is incurred over a year in maintaining that particular inventory. So if you differentiate this total cost per year with respect to Q, okay, so that shows the slope of this particular total cost curve. So the total cost, if you differentiate that with respect to Q, that is the order quantity Q, what you get is the slope of the total cost curve. So if you have a look at the figure that is given in this slide, you can see that this is the total cost curve. We have seen this particular curve earlier. So the total cost is determined as the sum of the carrying, ordering and the purchase cost. So this total cost curve, as you can see here, okay, it is maximum at the beginning at lower order quantities. It comes down, hits a minimum at a certain order quantity, and after that if the order quantity increases, then you see that the total cost keeps on increasing. So our objective here is to ascertain what is this particular quantity Q star equal to, that is the economic order quantity. So at this particular point where you have economic order quantity, you see that the slope of this particular curve is 0. Okay, so that occurs at a point of maxima or minima, and in order to determine a point of maxima or minima, we are taking this first differential. So taking the first differential of the total cost, we have already derived expression for the total cost per year. If you differentiate that with respect to Q, you will get the slope of this particular total cost curve. So the slope is denoted as dTC by dQ, is equal to differential of dp. Here d and p are constant, so differentiating with respect to q will yield a result 0. Okay, differentiating the second term with respect to q, here d and c0 are constants, so you have to take the differential of 1 by q, which is minus 1 by q square. So you end up with minus d by q square into c0 or co, sorry, not c0, co, plus the differential of this term with respect to q. So here again cc by 2 is a constant, so you take it out and you differentiate q with respect to q. So the differential of q is 1, that's why you end up with cc by 2. Okay, so if you take the first differential of the total cost per year with respect to q, you end up getting the slope of this particular curve. So this is the expression for the slope, and at a quantity, at economic order quantity, where the total cost is minimum, this is a point where the total cost is minimum. Okay, so the quantity, order quantity corresponding to which the total cost is the minimum is called as an economic order quantity. And at this particular point, you see that this is the point where towards the right of this point and towards the left of this point, towards the right and the left, you can see that the the total costs are higher than this particular point. So this is basically a point where the slope is 0. So at economic order quantity, the slope is 0. So hence what you can do is you can equate this particular term. You can write the left hand side of this particular term, that is dTc by dq, which is the slope, as 0. So when you write it down, 0 is equal to minus d by q square into co plus cc by 2. That's what you will get. So when you rearrange the terms, you can get d by q square into co is equal to cc by 2. And when you rearrange the terms, you will get an expression for q, that is q square is equal to 2COD by CC, where CO is the ordering cost per order, D is the annual demand, and CC is a carrying cost per unit per year. So hence Q, okay, Q will be the square root of 2COD by CC. And this particular Q is equal to Q star because you have found out this particular value of Q for the condition where the slope is equal to 0. Hence, the value of Q that you have computed is nothing but the value of Q star, which is nothing but the economic order quantity. So the economic order quantity for a purchase model with instantaneous replenishment and without shortages is given by the formula Q star is equal to 2COD by CC raised to 1 by 2, or square root of 2COD by CC. Okay, so taking the second differential of the total cost with respect to Q, if you again go for a second differential, you can see that again differentiating this particular term. Okay, here CC by 2 is a constant, so this particular value will go down to 0. Then what you end up with is minus 1 by q square, okay, or minus d by c0 is a constant. You have to take the differential of 1 by q square with respect to q, which is equal to 2 by q cube. So hence this second differential of the total cost per year with respect to q, that is d square tc by dq square, it will be equal to 2d by q cube into c0. Now this particular term is always positive because the annual demand per year, the annual demand, that is demand per year, cannot be negative. Q is the order quantity, it cannot be negative, and the ordering cost per order cannot be also negative. So none of these terms which are part of the second differential are negative. So hence the second differential will always be positive. So hence the point of 0 slope is a point of minima. We can ascertain that the point of 0 slope is a point of minima and not a point of maxima. Okay. Now the next kind of model that we'll be dealing with is a purchase model where we see instantaneous replenishment, but in this particular case, this is a model that allows for the inventory to fall below zero level. That is, it allows for shortages. So this particular inventory model can be depicted using a figure that is shown over here, where we see at time t equal to 0, the inventory level is at the maximum possible level. Okay, and we assume a constant demand. So the demand is generally constant. That's why you see the inventory level decreasing at in a linear fashion. So as time progresses, the inventory level decreases. At a time t equal to t1, okay, the inventory level has reached zero state. So from here on, there is no more inventory or no more amount of a particular item that can be supplied, even though there is demand for that particular item. So if we are maintaining a particular item in stock and we are using a purchase model which allows for shortages, now at a particular point of time, we'll come across a state where there is no more inventory for us to deliver that particular item when there is an order. But here what we do is we allow for that particular demand to continue, okay, and after a certain amount of time t2, from the point where the inventory level has hit 0, so after a time t2, after the inventory level has hit 0 state, we receive the order that we have placed. So somewhere between the maximum inventory level and time t1, so somewhere between t is equal to 0 and t is equal to t1, we place an order for the item to be restocked or refilled. So that particular order is not received when the inventory level has hit 0. That is what generally happens when purchase models which does not allow for shortage. By the time the inventory level hits 0, you generally have the order received. So in this particular case, the order is not received even when the inventory level has hit 0. So the inventory level goes into a negative condition, or there is a negative inventory or a stock out condition will exist. So even when there is a demand for an item, you do not have any stock to deliver. So such situation is referred to as a situation of negative inventory or stock out. Okay, so after a time t2, from the point where the inventory has hit zero condition or 0, then you receive that particular order, and here you instantly replenish the inventory level back to the maximum level. Okay, so the total time t, that's a time between subsequent replenishments. Here at a replenish, when you have an instantaneous replenishment, these replenishment conditions are indicated by maximum inventory levels. So at the start of this particular cycle, we have maximum inventory condition. So this is also a point that indicates say yes, replenishment. So this is also a replenishment point, and after we have passed a time equal to t, which is equal to t1 plus t2. So the total time is t1 plus t2. So after we have passed, or after time t has elapsed, we see that again a replenishment takes place. So the subsequent replenishments or refilling of stock takes place at an interval of t, which is equal to t1 plus t2. T1 is the amount of time, the time taken for you to reach a condition of 0 inventory, and T2 is the time taken from the 0 inventory condition for the order to be received. So the time between state of zero inventory to the receipt of the or reorder placed, that time is T2. So the total time T, for that is the time between two subsequent replenishments, is equal to T1 plus T2. Here the quantity Q is the maximum order quantity, or sorry, the economic order quantity. So the value Q is what we are supposed to find out, the value of Q. So Q is the economic order quantity, which is equal to Q1 plus Q2, where Q1 is a maximum inventory level. So the horizontal axis, that is a time axis, is a state where the inventory level is 0, and the point at which that particular inventory level graph starts is at maximum inventory level. So Q1 indicates a maximum inventory and Q2 indicates the maximum stock out or maximum level of negative inventory. So whenever there exists a condition where you have negative inventory or stock out, we assume that this particular order or this particular demand for products during the time where we do not have stock to meet that particular order, okay, or particular demand during the stock out period, then we assume that this particular demand during the stock out phase, which is equal to Q2, is satisfied at a later date with a penalty, and this penalty that needs to be paid is referred to as the shortage cost or the back order cost. Okay, so this particular value is represented as CS. So when compared to a purchase model without shortages, there are certain additional terms that come into play. Okay, the total cost is also determined as the sum of the purchase cost, the carrying cost, ordering cost. In addition to this, when you have a model with shortages, you have an additional element called shortage cost. Okay, and here the economic order quantity is again represented as Q, just as a previous case or previous model. The term is the same, it's Q, not exactly Q, it's Q star, and D is an annual demand or demand over a specific time period. CO is the ordering cost per order, CC is a carrying cost per unit per period, per time period, CS is shortage cost per unit per time period, Q1 is a maximum level of inventory, okay, and Q2 is a maximum amount of stock out that is allowed. So the derivation for the economic order quantity Q star is a very lengthy process, so you only have to study the formula for determining the value of Q1. So the value of Q star, sorry, economic order quantity Q star is slightly different from the formula that is used for purchase model without shortages. Here it is equal to root of 2 COD by CC multiplied by CS plus CC divided by CS. Okay, so it is 2 COD by CC into CS plus CC divided by CS, the root of the entire expression. Okay, that is the value, or that is the expression to calculate the value of Q star, which is the economic order quantity. So the difference is that you have an additional term when compared to the formula for calculating economic order quantity for purchase model with instantaneous replenishment and without shortages. Here in the model that allows for shortages, there is an additional term which is CS plus CC divided by CS, where CS is a shortage cost per unit per period, CC is a carrying cost per unit per period, CO is a ordering cost per order, D is the demand during the period. Okay, so with these terms you will be able to calculate the value of Q star, which is the economic order quantity. Then the maximum amount of inventory, the maximum inventory level Q1 star, okay, for economically maintaining inventory, the maximum amount of inventory to be maintained Q1 star is given by the formula root of 2 COD by CC multiplied by CS divided by CS plus CC. So here Q1 star, it differs from Q star for a model that allows for shortages in the fact that the second half of the term, that is this particular part, the reciprocal is used for determining Q1 star. Okay, so the difference between, you can relate between these two by just understanding the fact that you multiply 2 COD by CC by the reciprocal of CS plus CC by CS to determine Q1 star. So these two formulas are very similar. The only difference is the second half of the term. To determine Q1 star, you use the reciprocal of this term for determining Q1 star. Now, as you know, Q1 star and Q2 star and Q star are related by the formula. Q star is equal to Q1 star plus Q2 star. So therefore, Q2 star will be equal to Q star minus Q1 star. So this is very evident from this particular figure. The total inventory level Q is equal to Q1 plus Q2. Therefore, Q star will be equal to Q1 star plus Q2 star, where Q1 star is the maximum inventory, economic inventory, and Q2 star is the maximum economic stock out, and Q star is a maximum, or sorry, the economic order quantity is given as Q star. Okay. Now the problems regarding, or the problems based upon these models, we will discuss those problems in the next lecture, that is lecture 4 of this particular module. Now that we have discussed the inventory control models and we have derived formulas or understood formulas for calculating EOQs for purchase models with instantaneous replenishment, we will discuss these problems in lecture number 5. So lecture number 5 will be dedicated to problems related to economic order quantity calculations for both purchase models which allow for shortages and which does not allow for shortages. With this, we conclude lecture number 3. Thank you.